All right, we're going to go through the Chapter 7 review. This video will be for the first page. Okay, first question, we are trying to find the general solution to this differential equation. So when we are looking at that, we're looking for a solution. That means we need to separate out our variables and take the antiderivative. So the first thing we're going to do is separate out the variables. I know we normally don't add or subtract when we are doing this, but in this case, we are going to be doing that to get this dy over to the other side so that it's away from this piece right here, this 2x times y plus 1. So I'm going to rewrite this to be 2x times y plus 1 and add over that y, and then I'm going to rewrite it as dy dx so I can see the variables that I have. All right, and now to separate out the variables, I'm going to multiply both sides by dx and divide by y plus 1, so that I will have 2x dx equals y over y plus 1 dy. And now we're going to integrate. Over here, we're going to add 1 to the exponent with that x and divide by 2, and this is where I'm going to add my plus c. On the other side, we need to do some u substitutions. So I'm going to make my u y plus 1, and then I get my du, and it's dy, but I have this extra y up here at the top that I need to deal with. And so this is where we're going to do our double u substitution. And so I'm going to resolve my u as u minus 1 to give me my y. So in for y, I'm going to substitute in u minus 1. And in for y plus 1, I'm going to substitute in u, du. And I'm going to integrate that. When I integrate this side, I got to simplify first. I'm going to change it to be 1 minus 1 over u. Divide out both parts by u. And so when I take the antiderivative of 1 is going to be u minus the natural log of u. And I'm just going to bring this side down. And so then we can fill back in with what u is, so that we'll have x squared plus c equals y plus 1 minus the natural log of y plus 1. And this is pretty much going to be our answer here. There's nothing else we can really do. Normally we try and solve for y, but with both of the y's in there, we're not going to be able to solve that. So this is going to be our general solution here. All right, next one. Again, we're finding the general solution. So take and separate out the variables. So I'm going to go ahead right away and write it out as x dy dx. And I'm going to subtract over the 2y. Then to separate out the variables, okay, we're going to do a couple different things. I want to get the dy and the y together, but the dy has to stay in the numerator. Okay, so I'm going to think about multiplying it by dx on both sides. So then I can see where everything needs to end up going. My y needs to move over, and my x needs to move over. So then I'm going to have 1 over y dy equals negative 2 over x dx. And now I can integrate that my variables are separated. So we're going to have the natural log of y equals, this I like to think about it as negative 2 integral of 1 over x dx, because constants can come outside of that integral. So that's going to be negative 2 natural log of x plus c. Now in this case we can solve for y because there's only one of them. So we're going to go ahead and do that to solve for our general solution as y equals and put both sides in that power of e, so that I'll have y equals ce to the negative 2 natural log of x. And we can change this. Remember that log rule that we have that says if we multiply by negative 2 in that natural log, in front of that natural log, we can bring it up to be the exponent. So y equals ce to the natural log of x to the negative 2nd power. So my e and natural log will cancel each other out. C x to the negative 2nd, which would be the same thing as c over x squared. All right, again, we're going to find the general solution to the differential equation. So in this case, I'm going to add over the 2e to the x. So y dy dx equals 2e to the x. Separating out the variables is easy. In this one, we're just going to multiply both sides by dx. And then we can integrate. On the left-hand side, this is going to be 1/2 y squared. On the right-hand side, okay, again, we can move those constants out in front. We don't need u sub in this case. We can just move that out to the front. So that this is going to end up being 2e to the x plus c. Solve for y. There's just one y here. So in this case, I'm just going to multiply everything by 2 so that I have y squared equals 4e to the x plus c. This would be an acceptable answer, or we could go plus or minus the square root of 4e to the x plus c. Just make sure your plus c is underneath that square root. All right, last one on this page. Now we're going to go ahead and find that particular solution. So starting off the same way, x, y, dy, dx is going to equal the natural log of x. So to separate out the variables, I'm going to divide by x and multiply by dx. So I have y dy equals the natural log of x over x dx. And now we can integrate. Here, this left-hand side is just going to be power rule, straightforward. Over here, I need some u substitution. So u is that natural log of x. My du is going to be 1 over x dx. Perfect, which is what I have here in this integral. So this is going to become my du. Natural log is u. And I'm going to integrate this so that this right-hand side is going to be 1 over 1/2 u squared plus c, which we will fill in with the natural log of x squared plus c. All right, solving in this case for y, multiply everything by 2. So I have y squared equals the natural log of x squared plus c. Oh, and before I square root, I forgot this is a particular solution, so we're going to actually go ahead and solve for c. I'm going to do it right here in this step, because I don't want to have to deal with the square root if I don't need to. So I'm going to plug in 1, and I'm going to get an answer of 0. So my y value is 0 when I plug in 1. My natural log of 1 is 0, so this whole thing is going to cancel out. So 0 equals c. So that my particular solution is going to be y squared equals the natural log of x squared. And we can leave it like that. If you want to go y equals plus or minus the square root of the natural log of x squared, you could do that too. Okay. All right.